Today with section 11.6 we will be looking at the surface area and the volume of spheres. So before we get started we need to look at a couple of definitions that are a little bit different. In front of you you see a sphere, and one of the terminologies that you need to be aware of is known as the center. This would be the center right here. It looks like the radius, and it is the radius to an extent, but what the center is saying that it is equal distance from every point around the outside of the sphere, including this way, that way, and so on. So the center is the point that is at the very middle of the sphere. Beyond that, we have, just like everything else, we have the radius of the sphere, and if we went all the way across, it would be the diameter. Today we will be looking at two equations with regards to a sphere. The first equation is for surface area. Surface area is equal to 4 pi times radius squared. So pi r squared obviously is for the area of a circle, but in this particular shape for a sphere, you have to multiply the area of the circle times 4 to get the surface area. So the first example we will do with surface area of a sphere is actually example 1 is on page 639 in your book if you want to follow along. Otherwise you can just watch it on here. Basically you have a sphere here, and it shows you that the diameter of the sphere is 8. So if we're going to find the surface area, then we need to be able to find 4 pi times the radius squared. So in this one we see that we have the number 8, but that is the diameter. So as we know, the radius is half the diameter, so if we plug it in, it would be 4 pi times 4 squared. So the surface area would be 4 pi times 16, and 4 times 16 is equal to 64. And keep the pi, so if the answer asks you for in terms of pi, you would leave it as 64 pi meters squared. We'll do another example for the surface area. This can be number 6 on page 641. It asks you to find the surface area of a basketball with a diameter of 24 centimeters. So diameter equals 24 centimeters. And I want you to leave your answer in terms of pi. So we just continue on using the same equation, surface area equaling 4 pi r squared. So since the diameter is 24, surface area is going, or the radius is going to be 12. So surface area will equal 4 pi times 12 squared. Multiply that out, and it's 4 pi times 144. And if you plug that into your calculator, then you would see that 4 times 144 is equal to 576, and the pi is still there, so it's 576 pi centimeters squared. One of the more difficult aspects of Section 6 is going to be where you have to work backwards to get a random number in order to find the surface area. So we're looking at example 2, but I don't like that example, so we're going to be going over number 8 on page 641. It says, use the given circumference to find the surface area of each spherical object. We need to round our answers to the nearest whole number. So we need to find the surface area of a grapefruit with a circumference of 14 centimeters. So again, we're doing number 8. And it tells us that the circumference is equal to 14. Well, as we know, circumference is equal to 2 times pi times the radius. So if we're solving for that, then it's 14 equals 2 pi r. Well, in order to find the surface area, we need to figure out what the radius is. So we can go ahead and have the radius being equal to 14 divided by 2 pi. Just brought it over. and that can be simplified to radius equaling 7 over pi. From there, we just plug it into the other equation for surface area equaling 4 times pi times radius squared. Or in this case, surface area equals 4 times pi times 7 over pi squared. So when you work this out, you have the surface area, let me get the pen, surface area equaling 4 times pi. And when you have a square, you square the top and the bottom, so it's 49 over pi squared. When you plug it in or keep working it out, you get 4 times pi times 49 is 196 pi over pi squared. We have a pi on the top and a pi on the bottom, so you can cross that out and make that 196 over pi. So the surface area, because it asks for the answer to the nearest whole number, would be 62.38, I believe, which would equal 62, and the unit of measurement is centimeters squared. So basically you're going to be given some information on some of the problems on the homework, and you just have to work backwards to find the radius, or vice versa, in order to solve for this surface area. So we'll do one more, and I'll work through it, and then we'll move on to the next part. Number 9 on that same page tells you that the circumference of a bowling ball is 27 inches. So if circumference equals 27, then we know that 27 is equal to 2 pi r. So doing what we did last time, the radius would then be equal to 27 over 2 pi, but we can't really reduce this one, so we'll just leave it as that. So now we have to come over to the surface area, and we'll plug it in, is equal to 4 times pi times 27 over 2 pi squared. So now that we have our problem set up, we need to work through it. So the surface area is equal to 4 pi. And remember from last time, or the one we just did, if it's squared, you have to square the top and the bottom. So 27 squared is 729. And 2 squared is 4. And pi squared is pi squared. Okay, so if you put it all together, you have surface area equaling 2,916 pi over 4 pi squared. So if we reduce that, then you would get 729 pi over pi squared. From there we can get rid of the pi on top, and so surface area is equal to 729 over pi. Those would cancel out to be just 1. And if you plug that into a calculator, you have 232.04. Directions say to the nearest whole number, so the surface area would be equal to 232 inches squared. The second equation that you'll need to know for a sphere is the volume of a sphere. And as you see up here at the top, volume of a sphere is equal to 4/3 times pi times radius cubed. And notice it's cubed and not squared on this particular equation. So let's do example 3 on page 640. You can see it below. It gives you the radius of 6. So volume would be equal to 4/3 times pi times 6 cubed. Just in case you're not sure, that would be 4/3 times pi, and technically it'd be 6 times 6 times 6. So for this one, 6 cubed is 216, so the volume would be equal to 4/3 times pi times 216. And when you multiply 216 times 4, you get 864. So volume is equal to 864 pi over 3. In this particular case, it reduces easily to 288 pi. Now remember, when you're doing volume, it's cubic units, so 288 pi meters cubed. Number 12 on page 641 is another example of this. We'll do it real quick. In this case, it has the radius of 5 feet. Now remember, just like on the first part, the only thing you need to be paying attention for in this particular type of problem is if it gives you the radius or the diameter. So if it gives you the diameter, you need to divide it by 2 so that you can get it down to the radius. So from here, we just need to plug it in. Volume is equal to 4/3 pi times 5 cubed. 5 times 5 is 25. 25 times 5 is 125. So volume is equal to 4/3 times pi times 125, which ends up being volume equaling 500 pi over 3. The directions on this page tell you to give the answer in terms of pi and to the nearest cubic foot or cubic unit. So in this case, if you did it in terms of pi, it would be 500 pi over 3 feet cubed. And if you solved it out, you would find out that the volume is 524 cubic feet. Now, as always, we save the best for last and the hardest part for last. Example 4 in your book walks you through a process of taking a given volume of a sphere and working backwards to find the radius so that you can find the surface area. So we're going to work through Quick Check 4. And Quick Check 4 tells you that the volume of the sphere is 4,200 feet. So we know that from the previous equations that volume is equal to 4/3 times pi times radius cubed. So in order to get what we're trying to find right now is the radius. So let's plug in what we know, which is the volume is now 4,200. That's still equal to 4/3 times pi times radius cubed. So what we're trying to do is get radius by itself. So let's divide by 3/4. So you can do that two ways. One, you can type into your calculator as 4,200 divided by 0.75. Or you can do it the old-fashioned way, which is inverting the fraction and multiplying. Either way, it would get you the same answer, and you would have an updated equation of 3,150 is equal to pi times radius cubed. To get radius by itself, you divide by pi, so radius cubed is equal to 3,150 over pi. Now here's where it can get a little confusing. You need to take the cubic root, not the square root. So some calculators will have the cubic root. If you don't have the cubic root, you can download the free iPad calculator app and it's on there. But your equation would look like this. Radius would be equal to the cubic root of 3,150 over pi. On the calculator app, it's a little symbol that looks like this, the square root of y, or x to the y power, something like that. So you get your number that you want to take the cubic root of. So in this case, you would type in 3,150 divided by pi. Then you would hit this button, and then you would hit 3 and hit equals. And if you did that, your cubic root would be a number that would be something to the effect of 10.00, and then I forgot what the rest is. So basically 10. And that's your check see if you can figure out how to do it right. So if you don't know how to do it, ask someone around you, see if they can help you figure it out. But we have to find the radius in order to find the surface area. So from here, we would plug it in. Surface area equals 4 times pi times 10 squared. For homework purposes, because you have a couple of these on your homework, you would need to round the cubic radius or cubic root to just do it to the tenths. So this one would be 10.0. That's why I just have it as 10 up here. So now we know that the surface area is equal to 4 pi times 10 squared. 10 squared is 100. 100 times 4 is 400 pi. Now the question in the book asks you to round it to the nearest tenth. So if you multiply that out, you would get the surface area equaling 1,256.6 feet squared. I know this was a lot, so I'm going to do one more. At this point, if you think you understand it, you can go and start on your homework. But if you're still or would like to see another one worked out, I'm going to do one more, and then you can proceed to your homework. So the last example we're going to do is number 18 on page 641. It tells us that the sphere has a volume of 900. So when we plug it in, we have 900 equals 4/3 pi r cubed. And so what we're trying to do, just like last time, is get radius by itself. So when we get rid of the 4/3, invert and multiply, or we multiply both sides by 3/4, or 0.75, and that gives us 675 equaling pi r cubed. So when we get the radius by itself, r cubed is equal to 675 over pi. And here's where we take the cubic root again. So radius is equal to the cubic root of 675 over pi. Now, as I said, round it to the nearest tenth, which in this case gives you a radius of approximately 6.0. From here, we need to switch equations, and when we switch equations, we're going to go to the surface area, because that's what it's asking for. Surface area is equal to 4 times pi times radius squared, or in this case, surface area is 4 pi 6 squared. 6 squared is 36, so 4 times pi times 36. 4 times 36 is 144, with pi left over, and the directions say to give the answer to the nearest whole number, which in this case is 452, and its surface area, so it's squared, or inches squared, not cubed, inches squared. Okay, do your best on the homework. I will be back on Monday to go over it with you. If we have any questions, I know we'll probably have a question or two about the volume. But do your best. You should be able to get through everything else, though. Homework is online, and you have the rest of class to work on it.